Good morning, students. Good morning, students. Today we are going to cover this topic, tidal hypothesis of James, Jeans, and Jeffrey. So, yesterday we have covered an hypothesis of like the planetesimal hypothesis by Moulton and Chamberlain. Today we are going to cover this particular hypothesis, that is tidal hypothesis of James, Jeans and Jeffrey. So it's included under dualistic concept. Now introduction. So James Jeans proposed the tidal hypothesis to explain the origin of Earth in 1919. So basically he proposed the tidal hypothesis, this particular hypothesis to explain the origin of the solar system and Earth, all the planets included in it. And it was proposed in 1919. Harold Jeffreys later added some points making the hypothesis more detailed. So Harold Jeffrey joined the James Jeffrey to propose this particular hypothesis in more detailed form. According to this hypothesis, the sun was a huge rotating ball of gas. So according to this hypothesis, the sun was initially a rotating ball of gas. There was another star in space that is called the intruding star, which was much bigger than sun. So we have sun. So it's a dualistic concept, so two stars are included. So basically one is the sun and the another one is our intruding star. Main idea of this hypothesis: when this big star came near the sun, it created tides on the sun's surface due to strong gravitational pull. So when this big star came near the sun, that means this intruding star, it is much bigger than sun, and when it came near the sun, it created tides. Okay, so tides on the surface due to strong gravitational pull. So the star, this is the intruding star, this is the sun. So it came very close to the sun. So because of the gravitational pull of this big star, sun tides started to create on the sun's surface. So as you know, the tides appear on in the oceans like this. These are very huge. So similarly, on sun surface, huge tides are started to form. As the star came even closer, the tides on the sun became higher and stronger. So as this intruding star came closer to the sun, the tides on the sun started became higher and stronger. That means initially they are like this. Let me draw a good diagram. This is the sun's surface. This is hopefully now it's better, means it's understandable. So this is the sun's surface. So initially when this intruding star come nearer to the sun, small tides started to become. But as it comes closer to the sun, huge tides started to form. Okay, because of this external pull, a huge amount of gaseous material was pulled out from the sun. So sun was a rotating gas cloud according to this hypothesis. So due to the extreme gravitational pull by the intruding star, the a huge amount of gaseous material that is present in the sun started to come out. This pulled out material form a long cigar shaped filament of gas. So this pull down material form a long cigar shaped filament of gas. So what is this cigar shape? Basically, its cigar is the old secret, and you can search it on Google how it looks. This filament was thousands of kilometers long, thicker at the center and thinner at the ends. So here is a small description of the cigar shaped filament. So it is thicker, that means it is thicker at the center and thinner at the ends, something like this. Okay, or you can say something like this. Okay, so thicker in the middle and thinner at the ends. Genes call this gas filament a tidal filament. So the James genes call this filament the tidal filament. The filament got separated from the sun when the intruding star moved away. So this filament pulls out from the sun and it got separated from the sun and the intruding star moved away. Formation of planets. Now the question comes in your mind that how the planets and the solar system formed. The filament could not fall back into the sun or follow the star. So that filament, the cigar shaped filament that is pulled out from the sun, cannot fall back into the sun because it's very big and it's and it cannot follow that intruding star because that intruding star moved away very fast. It started revolving around the sun because of gravity. So because of the gravity, sun's gravity, this is the sun. So because of sun gravity, this uh, this you can say the star started to revolve around the sun. As it cooled, the gas condensed into liquid and knots, clumps started forming. So as it cooled, this as this you can say this filament started to cool down, the gas condensed into liquid. So this gaseous filament started to convert into liquid form and knots and clumps started forming. So the clumps are started to form in that filament. These nodes later condensed further and became the planets. So these are the clumps. Okay, so what does the clumps mean if you don't know? Like if you made a batter, okay, including the flour and water, things like that. So if some like clumps, we can say that clumps are started to form into that batter because you didn't stir it properly. So these are like big you can say this big clumps started to form in the batter. Okay, because you didn't stir the batter properly, that's why. So these clumps, similarly, this type of clumps started to form in that filament, which is converted into liquid state. These nodes, these clumps which are present in the filament later on became the planets. Because of the cigar shape, the planets formed were bigger in the center and smaller at the ends. So as we know that the cigar is the thicker in the middle and thinner at the ends. So the planets are also like this in the solar system. They are bigger, like the Mars and the Jupiter. These are the bigger planets. They are present in the middle of the solar system, and the Mercury, Venus, and then Uranus, Neptune, those are comparatively shorter. So those are at the end of this solar system. So this shape, this arrangement of the planets in the solar system resembles the cigar shape. Characteristics or supporting the hypothesis: if we arrange planets in a line, bigger ones are mostly in the middle and smaller ones at the sides, matches the cigar shape. As I've already explained you how the planets are arranged in the solar system, and they resembles the cigar shape. Satellites also show a similar pattern, supports the hypothesis. So the satellites of the planets resembles the same pattern, means the bigger satellites are present in the center, okay, and they are revolving around the bigger planets. Smaller planets cool faster, so they have few or no satellites. So the smaller planets like the Mercury, Venus, those, and like earth has only like one satellite. So those small planets cool very faster, you know, so they have no or very few satellites. Bigger planets remain hot longer, they cool, form more satellites. So the bigger planets, they remain hot for a longer period of time, okay, because if you boil this amount of water, it will boil very quickly, but if you have to boil a like huge tub, it will take a longer time. So similarly, what happens here? So satellites keep detaching from sorry satellites keep detaching themselves from the planets, from the bigger planets. Because of that, there are so many satellites of the bigger planets. All planets came from the same filament. Explain why they form at the same time and have similar materials. So all the planets came from the same filament, that cigar shaped filament. This explains that why the planets formed at the same time and with the same material. Because why? Because they form from the same filament. Now the critical analysis and the criticism that this hypothesis received are: critics like Delavin said stars are extremely far apart. Very low chance of a star coming so close to the sun. So critics like Delavin say that the stars are extremely far apart. So there is very low chance that any star will come closer to the sun and pull out huge amount of gaseous material from the sun. So that's what Delavin thinks. Russell argued that such a huge amount of material cannot be pulled out from the sun to form planets. So it is. He said that it is not possible to to pull out huge amount of material that can form bigger planets. You know, some scientists say that the filament would have cooled too quickly and planets could not form properly. So some scientists say that the filament would have cooled too quickly, and because of that planets are not able to form properly, and maybe not eight planets are able to form. Others say that filament might disappear due to extremely high temperatures. So some scientists say that the filament might be disappear. Why? Because at that time sun the filament is pulled out from the sun is very hot, and the um, near distance of the sun is also very hot. So because of that the filament that is pulled out from the sun might disappear. Okay, because it's in the gaseous form. So because of experiencing so much heat, it scattered away, the gas particles scattered away. Okay, because when the particles, because it is like sun is rotating gas of cloud, that what this hypothesis says, and that filament is also in the gaseous form. So after pulling out from the sun, the filament is in the gaseous form. So particles are far apart. As we know that the particles in the gaseous state are far from each other. So these are very far apart, and experiencing a lot of heat from the sun, these particles started to scatter away because they got the kinetic energy and they started to move like really quickly. So because of that, all the particles scattered away. So because of that, uh, so planets can't be formed because filament disappeared. Astrophysicists argued that the angular momentum given by the passing star was too low to explain the high angular momentum of planets. So, what does the astrophysicist argue? That the angular momentum meaning the movement. Sorry. So, the astrophysicists argue that the angular momentum, or we can say in a very simple language, that the movement given by the passing star, that is the intruding star, was too low to explain the high angular momentum of planets. So that intruding star, its gravitational pull give a very little movement. Okay, little movement to the, we can say, filament, and because the planets are formed from the filament only, so that intruding star has given a very small amount of movement to that filament from which all the planets form. So because of that, but now we can see that the angular momentum of the planets are much higher. So this can't explain that why the initially that the intruding star gives a very small movement. to the filament. But the planets that are formed from that same filament have more movement in them. They are rotating faster. So I hope this topic is clear to you all. If you have any doubt, you can ask freely in the comment section. And today's homework is to make a diagram of flowchart explaining this concept in your copy. And if you have completed this, write down done in the comment section. So that's it for this video. Thanks for watching.